So if we have all of these energy levels and sublevels and orbitals around our atoms, it would be a good idea to figure out, well, how do these electrons fill these orbitals? Do they go into the s first, or the p, or which energy level? And one way we can look at this is as a house, or dorm, or hotel room. So let's think about, here is our atomic hotel, and electrons need to come and stay. Electrons, being really small, don't have much energy, so we're going to say they're really lazy. So if you were an electron and you wanted to stay in this hotel and no one was in it, where would you go first? Well, if you don't have much energy, you're not going to bother walking up all the stairs. You're going to go in the room that's the lowest. So we are going to say your electron. I'm going to represent the electron with an arrow. I'll explain this reason for this in a little bit. But you're going to go in that first energy level. Now, the next electron wants to come in. Where's it going to go? Well, it's also lazy, and we're going to say that every room can hold up to 2 electrons. So this is a pretty big room, and the electron's lazy, so it's going to share the room, but it can't stay in the same bed, so it's going to be laying in the bed that's in the opposite direction. Well, now the next electron comes in, but the room is filled. The room is already filled. It can only hold 2 electrons. So the next electron will come into the next floor. It'll have to climb up a little bit. And if another one comes in, well, it's going to be lazy, and it'll only go to the second floor because the first floor is filled, and it will stay in the second bed. If the next electron comes in, well, now the first 2 rooms are filled. First 2 floors are filled, so it has to go to the 3rd floor. When it goes into this 3rd floor, it can pick from any of these 3 rooms. So there it goes. Now the question is, if another electron comes in, where is it going to go? So it has to go to this 3rd floor. Well, would it rather share a room or have a room to itself? Well, think about you. Would you rather have a room where you had to share with someone, or would you want to have as much space as possible? So electrons, because they are negatively charged, think about what negative charges do to each other. They repel. So because electrons repel, they are going to try to stay far apart from one another. So the next electron will go in a separate room. It's on the same floor, so it doesn't take more energy to go there. If another one comes in, it again does not want to share, so it'll go in its separate room. If now another electron, a 4th electron for this floor, comes in, it's not going to go to the next floor because there's still room here, but now it will be forced to share. So we'll have to force these electrons to stay in the room, and they will continue to fill in the rooms in this way. So what does this hotel example show us about where electrons go in an atom, or how do they fill the energy levels of an atom? And there are 3 different rules that we need to know. The first rule deals with how the electrons picked the energy levels, or the floors. And what we're going to say is that electrons always go to the lowest energy orbital that's open. And this is known as the Aufbau principle. And again, this says that electrons fill lower energy orbitals before they can fill higher energy orbitals. So electrons fill orbitals from low energy to high energy. The second rule that this example shows, this deals with how electrons would rather have their own room before sharing with another electron. And this is known as Hund's rule. Hund's rule states that one electron will fill each orbital of a sublevel before pairing in a single orbital. So that means you need to put one electron in each box, each orbital of a sublevel, before you pair them together. Electrons like their own room. The last rule that we need to know is the Pauli exclusion principle. The Pauli exclusion principle states that electrons want to sleep in their own separate beds. So electrons must be either spin up or spin down, which is what these arrows show. And in order to share an orbital, each electron must have a different spin. One is spin up, and one is spin down. And this is what I meant by these arrows before pointing up or down. An arrow pointing up means the electron is spin up. An arrow pointing down means the electron is spin down. And electrons must have opposite spins in order to exist in the same orbital.